Hello, this is Ring from Exam Help. Today I'll be solving Physics Paper 2 AS Level Structured Questions 9702 Paper 2 Variant 2 May June 2018. Question number 1, Part A, define force. So you need to write force in terms of change in momentum. So force is rate of change of momentum. Part B, state the SI base units of force. The force is mass into acceleration. So mass into acceleration is kilograms meters per second square. Part C, the force F between 2 points is given by the following equation, where Q1 and Q2 are the charges, R is the distance between the charges. This is a constant that depends on the medium between the charges. Use the above expression to define the base units of the constant. So constant is equals to product of both charges divided by 4 pi r square F, where charge into charge is ampere square into second square divided by meter square into kilograms meters per second square, and that brings us to ampere square seconds to the power 4 per kilogram per meter cube. Question number 2, Part A, state the principle of conservation of momentum. So this is total momentum before collision or explosion is equal to total momentum after explosion or collision for an isolated system. Part B, a stationary firework explodes into 3 different fragments that move in a horizontal plane as illustrated in figure 2.1. The fragment of mass 3m has a velocity of 7 meters per second perpendicular to line AB. The fragment of mass 2m has a velocity of 6 meters per second at angle theta to line AB. The fragment of mass 1.5m has a velocity of 8 meters per second at angle theta to line AB. Part 1, use the principle of conservation of momentum to determine theta. So momentum before explosion of 2m, 3m, and of 1.5m along vertical axis is 0, and that after explosion is 3m into 7 along vertical axis. So this is moving with vertical axis having a velocity 2m into negative 6 because it is moving downwards. So 2m multiplied by negative 6 sine theta, and the momentum after explosion of this mass 1.5m in the vertical component with vertical component of speed as 8 sine theta into 1.5m. So momentum before explosion is 0, momentum after explosion in the vertical axis is 3m into 7 plus 1.5m into 8 sine theta plus 2m into negative 6 sine theta. And this also needs to be negative because this is also moving downwards, so negative 8 sine theta. So this becomes 21m is equals to 24m sine theta. M and m on both sides, they get cancelled. So sine theta is equals to 21 by 4 and theta gets 61 degrees. Part 2, calculate the ratio kinetic energy of fragment of mass 2m and fragment of mass 1.5m. So 2m, fragment of mass 2m has a velocity of 6 meters per second and that of 1.5m is 8 meters per second. So 1 by 2 into 2m into 6 the whole square and 1 by 2 into 1.5m into 8 the whole square, and that gives me a ratio of 3 by 4. Question number 3, a child on a sledge slides down a steep hill and then travels in a straight line up an ice covered slope as illustrated in figure 3.1. The sledge passes point A with speed 18 meters per second at time t is equals to 0 and then comes to rest at point B. The child applies a brake to the sledge at point B. The brake does not keep the sledge stationary and it immediately slides back down the slope towards A. The variation with time t of the velocity v of the sledge from 0 to 24 seconds is shown in figure 3.2. Okay, so this figure 3.2 shows that from t is equals to 0 until t is equals to 12 seconds, the sledge was moving towards B from point A. Right at this point of time, the graph crosses x-axis, which means that from t is equals to 12 seconds until t is equals to 24 seconds, sledge moves towards A from position B and has a final velocity of 6 meters per second. So part 1, state the time taken for the sledge to travel from A to B. So this part of the graph is from A to B, and the time interval for it to reach position B from position A is 12 seconds. And this part of the graph from here until here, this is moving from B to A. Part B, determine the displacement of the sledge up the slope from point A at time t is equals to 24 seconds. So from t is equals to 0 until t is equals to 12 seconds, this is the distance it covers, meaning A to B, the distance this sledge is covering is this much. And from B to A, it covers this distance. Displacement is the shortest distance traveled by the sledge from starting point to the finishing point. So first of all, I'll have to calculate the distance the sledge covers while moving from A to B, and distance is area under graph of velocity versus time graph. So this is half of base into height, and this is also half into base into height. So half of base into height is from A to B, it travels half into 12 into 18, that's 108 meters. And from B to A, it travels this much, so half into 12 into 6, and that's 36 meters. So displacement is shortest distance from the starting point to the finishing point. So that's going to be the difference between these two distances. So 108 minus 36, it gives me 72 meters. So the displacement from time t is equals to 0 to time t is equals to 24 seconds is of 72 meters. Part C, show that the acceleration of the sledge as it moves from B back towards A is 0.5 meters per second. So acceleration is equals to final velocity minus initial velocity divided by time. For the part of the traveling of the sledge where it moves from B to A, it has an initial velocity of 0 and final velocity of 6, and the time interval for this change of velocity is 12 seconds. So 6 minus u divided by 12, and that's 0.5 meters per second square of acceleration while it moves from B to A. Part D, the child and sledge have a total mass of 70 kilograms. The component of the total weight of the child and sledge that acts down the slope is 80 newtons. Determine the frictional force on the sledge as it moves back, from B towards A. So let's suppose that this is point A and this is the hill it's gonna be moving. So this is point B. This is the horizontal level. This is the sledge, which weighs 70 kgs, and 70 kgs means that 70 into 9.81 of newtons of the force is acting vertically downwards. It says that the component of the total weight of this child and sledge that acts down the slope, and that component they are talking about is this one. So this is of 80 newtons. It is moving downwards from B towards A. That means frictional force acts upwards. This is the frictional force. So since sledge is able to accelerate, it means that its force that's driving it down is bigger than the frictional force. So 80 newtons is much bigger than the frictional force, so I'll assume that it is of x newtons. This is equals to mass of the child and sledge is 70 into the acceleration from B to A from the previous part is 0.5 meters per second square. So, and that's how we get a frictional force of 45 newtons. Part 2, the angle theta of the slope to the horizontal. So angle theta is going to be this one, and we know this is the sledge. This is acting vertically downwards. So this is 17 to 9.81, which is 686.7 newtons. And the horizontal component, which acts downwards, is of 80 newtons. And you must remember that this theta is equals to theta over here. So to calculate this theta, we have the formula sine theta is equals to the opposite side to it is 80 newtons, and the hypotenuse side of this angle is 686.7. So this way we get theta of 6.7 degrees. Part E, the child on the sledge blows a whistle between 4 seconds and 8 seconds. The whistle emits sound of frequency 900 Hz. The speed of the sound in the air is 340 meters per second. A man standing at point A hears the sound. Use figure 3.2 to determine the initial frequency of the sound heard by the man. So they're asking us to calculate the observed frequency. The frequency of the sound source is 900 Hz. Speed of sound in air is 340 meters per second, and speed of the source of sound is the speed with which this sledge starts to move at t is equals to 4 seconds, because they're asking us to find the initial frequency, means at time t is equals to 4 seconds. So that can be achieved from figure 3.2, that at time t is equals to 4 seconds, the sledge has a speed of 12 meters per second. So we can assume that speed of the sound source is 12 meters per second. The formula is observed frequency is equals to frequency of source multiplied by speed of sound in air divided by speed of sound in air, and in this case we will add speed of sound in air and speed of the sound source, because this child is moving away from that man who is standing at position A. And remember that until t is equals to 12 seconds, this sledge is moving towards point B from position A. So 900 into 340 divided by 340 plus 12, and the initial frequency being heard by the man is of 869.3 Hz. Part 2, describe and explain qualitatively the variation, if any, in the frequency of the sound heard by the man. So at time t is equals to 8 seconds, it can be deduced from figure 3.2 that it has a much lower velocity as compared to that at t is equals to 4 seconds. At t is equals to 4 seconds, the velocity with which the sledge moves toward point B is 12 meters per second, and at time t is equals to 8 seconds is going to be 6 meters per second. So it has decreased by half. So when the velocity decreases by half, the velocity of the source of sound decreases. This will increase the observed frequency. So we can write that velocity of sound source decreases and observed frequency increases. Question number 4, part A, define the wavelength of a progressive wave. So that's distance between two adjacent wavefronts. Part 2, state what is meant by an antinode of a stationary wave. So that's a point where amplitude is maximum. Part B, a loudspeaker producing sound of constant frequency is placed near the open end of a pipe. As shown in figure 4.1, a movable piston is at distance x from the open end of the pipe. Distance x is increased from x is equal to 0 by moving the piston to the left with a constant speed of 0.75 centimeters per second. The speed of the sound in the pipe is 340 meters per second. A much louder sound is first heard when x is equals to 4.5 centimeters. Assume that there is an antinode of a stationary wave at the open end of the pipe. Determine the frequency of the sound in the pipe. So for frequency, we need to have the speed and the wavelength of the sound wave. And for wavelength, we know that the first sound is going to be heard when x is equals to 4.5 centimeters, and that's possible when this pattern of wave forms in the pipe, which is fixed for a tube that has an open end and a closed end. So this tube is of length pi by 4, which is equals to the length of the pipe, which is 4.5 centimeters, which we'll convert to meters. And so we can write that the wavelength is of 0.18 meters. When we now have the wavelength and the speed of the sound in the pipe, we can actually calculate frequency, which is speed divided by wavelength, and that's 1888.8 hertz of frequency of sound in the pipe. Part 2. After a time interval, a second much louder sound is heard. Calculate the time interval between the first loudest sound and the second loudest sound being heard. Okay, so second much louder sound would have a waveform like this. Every time you draw this waveform for a tube like this, which has an open end and a closed end, an antinode must be at the open end and the node should be on the side where it is closed. So length of this tube is now 3 by 4 of wavelength, and 3 by 4 of wavelength means 3 by 4 into 0.18 meters, which is the wavelength. That's 13.5 centimeters of the length of this tube. So the previous length of the tube when the first loud sound was heard, it had a length of 4.5 centimeters, and now when second much louder sound was heard, the length of the tube was 13.5 centimeters. And in the beginning, it is told to us that x changes by 0.75 centimeters every second. So this means that 13.5 minus 4.5 divided by 0.75, which gives us 12 seconds. So 12 seconds is the time interval between the first and second louder sound being heard. So the time interval is of 12 seconds. Question number 5. A solid cylinder is lifted out of oil by a wire attached to a motor. Figure 5.1 shows two different positions x and y of the cylinder during the lifting process. The motor is fixed to an overhead beam. The cylinder has cross-sectional area, length, and weight. The density of the oil is 940 kilograms per meter cube. Throughout the lifting process, the cylinder moves vertically upwards with a constant velocity of 0.02 meters per second. The viscous force of the oil acting on the cylinder is negligible. Calculate the density of the cylinder. So density is equal to mass of the cylinder, which is 560 divided by 9.81 divided by the volume of the cylinder, which is area into length. So 0.018 into 1.2, and the density of the cylinder is hence 2642.8 kilograms per meter cube. Part B, for the cylinder at position X, show that the upthrust due to the oil is 200 newtons. So to find the upthrust force on the cylinder by the oil, we need to first have pressure due to oil on cylinder. So pressure of a liquid can be found by using the formula density into 9.81 into height. So density of oil is 940 kilograms per meter cube multiplied by 9.81, and the depth at position X is of 1.2 meters. So this gives us the pressure 11065.68 pascals of pressure due to oil on the cylinder. Now pressure is equals to force divided by area. Pressure due to oil is 11065.68, and it exerts this amount of pressure on 0.018 meters square of cylinder, and that gives me the upthrust force due to oil on the cylinder, and that's 199.2, which is also equals to 200 newtons. Part C, calculate for the moving cylinder at position X. Part 1, the tension in the wire. So since cylinder is moving with constant velocity as it is stated right over here, the tension of wire and the upthrust due to the oil must be equal to the cylinder's weight. Because suppose this is the cylinder and the weight acts right from the center, the upthrust acts upwards and the tension also acts upwards. So tension plus upthrust is going to be equal to the weight. So weight, which is of 560 newtons, minus the upthrust force, which acts due to the oil, that is of 200 newtons. That will give me 360 newtons of tension. Part 2, the power output of the motor. So power is equals to tension force multiplied by distance this cylinder is going to cover, and divided by the time interval. So force is going to be of tension force, that is 360. It travels a distance of 1.2 meters, divided by the time interval for this distance being covered is going to be can be calculated by using this value. It is stated that cylinder moves 0.02 meters every second. So to cover a distance of 1.2 meter, it takes in total 60 seconds. So 360 into 1.2 divided by 60, that's 7.2 watts of power. Part D, the cylinder is raised with constant velocity from position X to position Y. State and explain the variation, if any, of the power output of the motor as the cylinder is raised. So when cylinder starts to get onto surface of oil from position X to position Y, the depth of cylinder in that container decreases, which decreases upthrust force on the cylinder since they are directly proportional with each other. As a result, tension needs to increase from 360 newtons to balance it with cylinder's weight of 560 newtons, because the cylinder has to move with constant velocity as it is written here, and they both act in opposite directions, the weight of the cylinder and the tension in the wire. So power output of the motor increases too. So we can write that depth decreases, which decreases upthrust. In order to make the cylinder move with a constant velocity, tension needs to increase too. So tension increases, and when tension increases, power output of motor increases too. Part 2, the rate of energy output of the motor is less than the rate of increase of gravitational potential energy of the cylinder. Without calculation, explain this difference. So while it is moving from position X to position Y, the upthrust has not totally got zero. There is still upthrust, but it starts to decrease while this cylinder tries to get onto the surface of the oil. So there is work done by the upthrust force too. Question number 6, A, state Kirchhoff's first law. So sum of currents entering into a junction is equal to sum of currents leaving that junction. Part 2, Kirchhoff's first law is linked to the conservation of a certain quantity. State this quantity. So this is charge. Part B, a battery of electromotive force 8 volt and internal resistance 2 ohms is connected to a resistor X and a wire Y as shown in figure 6.1. The resistance of X is 15 ohms. The resistance of Y is Ry. The current in the battery is 2.5 ohms. Calculate the thermal energy dissipated in the battery in a time of 5 minutes. So energy dissipated in battery is due to lost volts in the internal resistance of 2 ohms of the battery. So lost volts are 2 into 2.5, that's resistance into the current across the internal resistance, which is equal to 5 volts. So energy dissipated due to internal resistance is going to be 5 into the current into time interval, which is of 5 minutes. We need to convert that to seconds. And so energy dissipated is 3750 joules. The terminal potential difference of the battery, so PD is equals to EMF minus lost volts. EMF of the battery is 8 and the lost volts due to battery's internal resistance are 5 volts, and that's 3 volts of PD. This means that a PD of 3 volts is across 15 ohms of resistor X, and PD of 3 volts is also across wire Y. But to determine the resistance Ry, so by using Kirchhoff's second law, which is related to conservation of energy, which is that EMF is going to be equal to sum of PDs across loops plus the lost volts. So EMF of the battery is of 8 volts. This is going to be equal to lost volts, which is 2 into 2.5, that's 5 volts, plus PD across resistor X and PD across YY. So PD across resistor X is going to be 15 ohms into the current across this. Let's suppose that 2.5 amperes of current is in this. X amperes of current enters this loop and the remaining continues to flow across YY. So this will be 2.5 minus X. This means that voltage across 15 ohms is going to be 15 multiplied by this current, and the voltage across YY is going to be equal to 2.5 minus X, the whole multiplied by the resistance of YY. So voltage across 15 ohms of resistor is going to be 15 into X plus voltage across resistor Y is going to be Ry into the current across this, which is 2.5 minus X. And we already know that PD of battery is 3 volts. This means that PD across resistor X is 3 volts and PD across resistor Y is also 3 volts. So through this we can actually get the value of X, which is 0.2, and now when you substitute this into this equation, you will have the resistance of wire Y, and that would be equal to 1.3 ohms. Part 3, a new wire Z has the same length but less resistance than wire Y. State 2 possible differences between wire Z and wire Y that would separately cause wire Z to have less resistance than wire Y. So the formula is resistance is equals to resistivity into length by area. They both share the same length, but wire Z has a much lower resistance. This means it could either have a lower resistivity or it could have a greater cross-sectional area. So the first difference could be that wire Z has lower resistivity. That's why it has a lower resistance as compared to that of wire Y. Or the second difference could be related to cross-sectional area. Since they are inversely proportional to each other, area could be greater in wire Z. So Z has greater cross-sectional area. Wire Y is replaced in the circuit by wire Z by considering the current in the battery state and explain the effect of changing the wires on the total power produced by the battery. So resistance is directly proportional to voltage but inversely proportional to current. Wire Y is now being replaced by wire Z, which has a lower resistance, means it draws higher current from the battery. And according to the formula, P is equals to I into V. When I increases, power output from the battery will also increase. So as a result, total power being produced by the battery increases too when we replace wire Y with wire Z. That's due to increase in current. So we'll write current increases. And so power produced by the battery increases. Question number 7. A stationary nucleus X decays to form nucleus Y as shown in the equation. Part A. In the above equation, draw a circle around all symbols that represent a lepton. So beta minus particle is a lepton as well as this antineutrino. State the name of the particle represented by this symbol. So this is antineutrino. Part C. Energy is released during the decay process. State the form of the energy that is gained by nucleus Y. So it's kinetic energy. Part D. By comparing the compositions of X and Y, state and explain whether they are isotopes. So let's suppose that X had a nucleon number of A and a proton number of B, and a beta minus particle has a nucleon number of 0 and a proton number of -1. Antineutrino has got neither. So Y will have a nucleon number of A and a proton number of B plus 1. And you know that isotopes, they share the same proton number, but they have different nucleon numbers. So in the case of X and Y, they have got the same nucleon numbers, but different proton numbers. So on this, we can come on to conclusion that the X and Y are not isotopes. So we can write that Y has one more proton than X and same nucleon number. So they are not isotopes. Part E, the quark composition of one nucleon in X is changed during the emission of a beta minus particle. Describe this change to the quark composition. So at emission of beta minus particle, a down quark changes to an up quark. So that was the end of the paper. Thank you for watching.